So this is a piecewise function, and the idea is that a function is defined in two different ways. Sometimes the function looks like 2x, sometimes the function looks like x plus 3. And we decide which of those formulas to use by this rule over here. So this is saying for any x value that's less than 1, I'm going to use this formula. And for any x value that's bigger than 1, I'm going to use this formula. So for instance, f of 0, well, 0 is less than 1, so I'm going to use this formula. I'm going to have 2 times 0, which is 0. Remember, a function can only have one output for each input, so I don't use both of these. I use one or the other. F of 1, well, 1 is here. 1 is less than or equal to 1, so again, I'd use this formula. 2 times 1 is 2. But if I put in f of 1.5, that's a number that's bigger than 1, so I'm going to use this formula. It's going to be 1.5 plus 3, which is 4.5. So what you often are going to do is come up with a graph for these piecewise functions, and the graph again is going to be kind of separate. At x equals 1, it's going to switch from one function to the other function. So for all the x values that are less than 1, it's going to look like 2x. And 2x is this line that has a slope of 2 and a y-intercept of 0. So it's going to look just like this line all the way up to and including the value of 1. But as soon as I hit anything larger than 1, it's going to switch, and then it's going to look like the function x plus 3. So that function has a slope of 1 and a y-intercept of 3, but I don't want to draw this portion of the line because it only starts there when x equals 1. Right? Notice f of f of anything just like a tiny bit bigger than 1 would just be like a little bit bigger than 4. So it's going to look like this. It has a slope of 1. So this is going to represent my piecewise function, the x's, and determine which of the formulas I'm using. So hopefully that helps.